Let's move on to our next session in this particular segment of our program. And we'll look at the generation of declarative transformation from semantic models. And in order to do so, I'll give the floor to Vladimir Alexiev, who's Chief Data Architect of Ontotext, the Knowledge Graph Solution Group. Good afternoon, Vladimir. I'm afraid you're on mute. Vladimir, we cannot hear you. We can see you, but we cannot hear you.
Sorry.
Yes.
I was wondering if I can share my own screen or...
I'm turning to the tech team. I think that's possible. Yes.
Okay. So let me share. Okay, good.
There we are.
So I'm very glad that my presentation is after Enrico's presentation, because he described a language for transforming data based on Sparkle, whereas what I want to do is generate such transformations, because there's a lot of repetitive stuff. I mean, you can do very powerful things with Sparkle, but in normal data modeling and data transformation tasks, the 80% of stuff that you need to do, you can actually generate it. So here's an outline of the presentation. I'll describe these three tools. RDF Pumo generates models or diagrams out of turtle examples of RDF graphs. Pumo comes from PlantUML, which is a very nice tool that generates all kinds of diagrams, including UML diagrams. RDF to Sparkle generates tabular transformations in Sparkle for Tarko and for our own OntoRefine. And RDF to RML generates R to RML transforms from the same examples. So there is a blog or a page on our website about the 10 steps of building knowledge graphs. Ontotext, by the way, has worked with semantic technologies for 23 years, and this is what we do on a daily basis. A lot of our business is to help our clients build knowledge graphs. So I think this presentation is mostly about these steps. Number 4, create a semantic model, and number 5, generate transforms or mappings from the source data to knowledge graph data. Okay, so for semantic modeling, I think many people equate semantic modeling to ontology engineering, but for me the two are different, because semantic modeling is about researching existing data standards and data sets and figuring out how to harmonize them, and then knowing and reusing existing ontologies, understanding the trade-offs between ontologies, for example, the different cognitive commitments that are made by different ontologies that hamper reuse quite often, and then extend ontologies with your own class and properties when needed, and make holistic models either in the shape of application profiles or these models that I will show, or RDF shapes such as Shako and checks, to describe how the different pieces come together, what you expect to be in your knowledge graph. And so for me, semantic modeling should come first. We'll quite often work with examples showing how we want the data to be laid out. And later on, we map it to ontologies or create our own ontologies or extend existing ontologies. A related topic is polyglot modeling. So despite the huge growth of knowledge graphs in recent years, still the majority of the world uses JSON or Elastic and various other data technologies. And in addition to RDF and its modeling languages or schema languages like Shako, XML, and RDFS, there is also JSON schema or the Elastic object model and so on. So the idea of polyglot modeling, and you can explore these links later, is to have a single source of describing a data format and then being able to extract different technical artifacts. 2 presentations ago, we talked about XML and XSD and converting that to RDF and checking it with Shako. Well, an analog in JSON could be JSON schema and so on. So my point is that data models are more fluent, and being able to move from one to another can be quite useful. sometimes. So this is, it's an open source tool. This is the GitHub location. And I'll first describe RDF Puma. So it allows you to specify very precisely how your semantic data model looks like, including URL patterns and data types and language tags on the literals that you want to use, how you combine or split fields and so on. So there's no hand waving. It's not just a conceptual diagram, but a very, very precise diagram. I started working on this 7 years ago, and it has been used daily in Ontotext by various groups, by maybe more than 50 people, and by some of our clients now. So this here is a model of Crunchbase, which is a data set of companies. It has a total of 20 million rows in 18 CSV tables. This includes 2 million companies, 1.5 million people, investors, funding rounds, initial public offerings, and so on. And out of this model, we generated 18 transforms for the 18 tables. And then using our Onto-Refine tool, we're able to RDFize the complete Crunchbase within 10 or 15 minutes to load it into GraphDB, because you don't need to create an intermediate file. It is streamed from an Onto-Refine Sparkle transform right into GraphDB. And also the daily update, let's say that there's about 1,000 rows changed every day, it only takes 1 or 2 minutes, because we use named graphs to replace basically the payload of triples coming from one row of the table. Now we are going to focus on only one of these nodes, which is an initial public offering. And this basically is a piece of turtle which says what fields there will be in these nodes, what is the type of the node, what is the URL pattern for the node. Here we use the UID field inside the URL, two fixed words, like so it's a pattern URL, two fixed words and a variable is substituted. We also show what data types are used for the different fields, and we have a few data manipulation functions. So here fixed date replaces a space with a T, stuff like this. Now I'll talk about generating tabular transforms. So this tool can generate Sparkle for 3 different transformers. One is for Onto-Refine, an update, Sparkle update, or a Sparkle construct for Onto-Refine, and with Tarkle, which is a standalone command line tool, you can only use construct. The disadvantage of construct is that you must create an intermediate file, okay? So this means that you first generate a big turtle file, and then in a second step you need to load it. Also, you cannot do updates with construct. Whereas with the Sparkle update, you can improve the speed. You can also use data that is already in your RDF repository and join it up to tabular data to resolve a thing to a string to a thing, for example. And we also use macros, kind of like sort of functions. So here we use two functions. Urlify replaces an English phrase, replaces any punctuation with an underscore to end up with something that is usable for a URL. And if not new is a custom function, you can see here it throws away non-useful values like other not provided and so on. And the scripts chain up these macros so that everything comes out right at the end. This is an example of a generated transform. So here on the left is the turtle with embedded source fields in parentheses, okay? And here on these two pieces on the right, the middle and the right side, is the generated Sparkle transform. It starts with a delete graph. So we use one graph per row, and that's why it completely replaces that row. And then it calls out into the Onto-Refine virtual Sparkle endpoint. And then it does an insert, and you can see that the shape of the insert exactly matches the shape of the turtle in the left column. And then comes a whole bunch of binds that compute various things. They attach data types to fields, they do some replacement, and they resolve the pattern URLs. Now, the nice thing about generation is here you have a much more complicated model for the same table of IPOs, initial public offerings. This uses the FIBE ontology, a foundational ontology in the financial domain. But it is a lot more complicated. You see, rather than one node, we have like 25 nodes. Boom, we run the transform. So here on the left is, no, this whole screen represents the turtle model. So you see that instead of 20 lines, it is maybe 150. But the generated sparkle, that's not even half of it. The generated sparkle is 300 lines, okay? And now the last part of my presentation is about generating R2RML transforms. This is the W3C language for relational databases. You can use it either with an ETL or with a no ETL approach. So the On2P software is integrated in GraphDB, and you can use it either back or forward.
Vladimir, I'm afraid you've only got, you've reached actually the end of your presentation time if we want to take questions. So I'll allow you 30 more seconds to maybe go to the main conclusion of your presentation so that we can take questions.
Okay. So the main conclusion is just like for tabular data, for relational transforms, again, this one node from this model gets expanded to these 15 nodes in R2RML. There are shortcut languages like YARML to write something like this, but I think that being able to write it in Turtle and see exactly how the turtle looks and have obvious connectivity between the nodes and make sure that the URL patterns are correct so that everything connects together is a major benefit of our approach. So here's the generated R2RML. This is another model, and you see here many nodes. This is on the left side is the source turtle, and the right 4 columns represent the generated R2RML. So yeah, we are happy if people use this open source, and we can help you get into it and improve and streamline your knowledge graph building projects. Now let's see if there's some questions.
Thank you very much. We do have a question, and indeed it touches upon what you were just saying. Is it advised to build your own knowledge graph instead of using an already existing and freely available one, such as Wikidata?
Oh, we use Wikidata in many of our projects. For example, we did a project with the Swiss interchange, SIX, Swiss Information Exchange. So that's the company that runs the Swiss Stock Exchange and the Spanish Stock Exchange. And it was a proof of concept of building up an entity knowledge graph. In other words, integrating data about their internal clients with external data about these companies. And we got some information from Wikidata. We matched by something like 15 types of IDs, by website as well, and so on. So yes, whenever there is good data, like for example, for geographic data, we always advise our clients, don't build another gazetteer of the world. Use geonames, for example.
Okay.
Yeah,
And
Wikidata is nice. We've contributed a lot to Wikidata as well.
good. And we have another question. Are there any fallback mechanisms included?
What is meant by fallback? Well, you can add some simple data munging, but basically you need to wrap it up in macros because in the model you cannot invoke functions. Or well, you can just say invoke this function on this part of the on this field, but you cannot use, for example, quotes or pluses or whatever. So yeah, you can add some functional transformations.
Thank you very much, Vladimir. Thanks for being with us and thanks for taking us through your presentation. I think you have definitely answered the questions very clearly. So thanks for that.